And without further ado, I'd like to introduce Mark Berry. Welcome.
Good morning, everybody. Thank you for coming today, and thank you, Greg, for inviting our organization to come and speak to you. It's our commanding officer, Captain Rothenhaus, sends his apologies that he can't come, and he sent me as his replacement. And so I thank you for all coming to do this. So this summit, this conference, is I got introduced to it a couple of years ago, and I'm quite pleased that to be a participant in this, because it's an important function that we all work together, and that in the maritime domain that we have a relationship and a teamwork in how we do that. It's kind of, I found this quote that Henry Ford actually said was, coming together is a beginning, keeping together is progress, working together is success. And so I want to talk a little bit today about how the Navy, a very large participant in the maritime domain, and the technology and the teaming part that contributes to generation of technology and moving this field ahead. And so I'm going to talk very simply a little broad picture about the Navy, and specifically related to San Diego County, and then talk quite a bit about our organization, Space War Systems Center Pacific, and then talk about a few little technology pieces. I can't talk about them all. There's I could spend many hours doing that. There's a lot going on in this area. So, and then I'll finish up and talk about the Navy's new class of ship that it's working on the research and development on, and that's the active program that DARPA has been doing, and that it's called, the ship is called the Sea Hunter, and it's been labeled as the Future Robotics Warship. So I'll finish up with a couple of topics related to that. So just kind of focusing here in San Diego is that the Navy has a very large impact in San Diego, and we are a huge contributor to a large set of development and activities and partnerships and demonstrations that happen here, including our active duty and our acquisition community, which ends up being where I fall into the research and development. So back in, very recently on November 1st, the San Diego Military Advisory Council released its military impact study. And just a couple of points out of that large document talking about all the impact that's here in San Diego is that it specifies in there that there's a total of about $23 billion that is spent in San Diego in direct spending related to defense that was sent here. And so in that, it contributes a huge amount to what is operating here. So about 20% of the region's gross regional product is sourced or comes from naval spending. So it's a very large impact, and the work that's going on is from active duty all the way through developing of systems and testing and evaluation. So there's a large span of work that's happening on there. And the report says that that the economics in San Diego may flatten out, but one of the things that is growing is that currently there are 53 ships that are stationed here in San Diego, and that's going to grow to 84 ships by 2023. So at least there's going to be a growth there. And so one of the summaries related to that study ends up saying that San Diego is the world's largest military concentration and spending in the world, which seems like a very important and a very, I didn't realize that it was that big of an impact. So let me get a little bit more in specifics related to the community that I'm involved with. And so in the Navy, there's a research development establishment, which starts from There's a whole list of abbreviations and acronyms that are on this slide, but let me tell you that this slide is the Navy's organization of the developing entities of the scientists and engineers that go towards building the next set of systems for the Navy. So the ones that are in yellow, those 8 that are listed there as the primary R&D centers, they focus either on working from left to right as the Naval Air Warfare Center, which develops all the aircraft-related technologies. Then in the center, the Naval Surface Warfare, which does all the surface ships technologies and systems. NUWC, that's the Naval Undersea Warfare Center, which is responsible for all the undersea-related products and systems. And then finally on the far right is SPAWAR Systems Center. SPAWAR is the Space and Naval Warfare, and the technology development arm ends up being the organization that I'm from. It's the SPAWAR Systems Center. So in those sets of organizations, each one has that are listed there in the yellow are primarily scientists and engineers who are developing, supporting the current set of systems and developing the next generation set of systems for the Navy. So specifically, the organization I work for is SPAWAR Systems Center Pacific. Our primary mission is, I didn't list it off as undersea, surface, or air, because ours is, as it says right there, is to do the research and development and support for integrated C4ISR, command, control, communications, computers, intelligence, surveillance, reconnaissance. You work for the DoD, you add a lot of acronyms to try to shorten up these things. So C4ISR, and we do that in relationship also of cyber and space operations. So it's from seabed to space, and we make this integration of those other systems better. And so we add the smarts, the command and control, the communications, the intelligence, some of the sensor systems, et cetera, that are listed there. So basically, we're working on trying to do the connectivity for all of these items. In the picture there on the left is Point Loma. We're located here in San Diego on Point Loma, just a couple of miles from here. We operate and participate in a variety of systems. The picture in the green there is the ONR's unmanned, large diameter unmanned underwater vehicle. We've had a long history in the marine mammal program for the Navy. We are the Triton that's shown there is we're responsible for the communication systems. On the far right with the rack of equipment, we're involved in doing the retrofitting the entire Navy with modern computer systems and ripping out all the existing and on every single ship and putting back new ones. Satellite systems, we're involved in the command and control on the ground systems and the design and system engineering support related to that. A huge set of mission areas that we're responsible for. So we've been in existence for over 75 years and started our history basically before World War II. In World War II, we were called the Navy Sound and Radio Laboratory. In that role, we developed a lot of systems of sonar systems, a lot of radar systems, a lot of radio systems. So we were at the forefront of satellite communications, how to get satellite comms out to Navy ships. We've developed the first digital tactical data systems. Everything before there was the whiteboards and voice comms, and so we created the first system for that. Moving over, we've done things in basic research. We were one of the first ones to develop a liquid-based laser system. On the bottom left, we've done a lot of work in acoustics and underwater acoustics related to torpedoes or sensing systems. We've done a lot of unmanned undersea vehicles. So for example, that unmanned system there is in 1966, it's the Curve. It was the cable undersea robotics vehicle, and it was deployed at that time to help as a surveillance and work system to recover the hydrogen bomb that was fell off into the ocean off of Spain. We were there to help recover it, and then several years later, we were also there to help using an upgraded system of that to rescue the sailors that were on the British submarine that was got into trouble at that point. We were part of the original research and development network for DARPA on the ARPANET. We were node number 3 on that network, and we are currently the chief engineer for the defense R&D network that runs amongst all the R&D organizations in the DoD. So that was a great history. We were also part of the development team that was related to the personalized assistant that learns, PALS. In that was working with a company that was bought up. That company was Siri, and so today it's transitioned off into products that many of us have in our cell phones. So just to give you a profile of our organization and what we're made up of is we're Navy civilians. We work for the big, long chain of command. We work for the Secretary of Defense, the Secretary of the Navy, and there are approximately 4,800 of us civilians that are located here in San Diego. The majority of those are scientists, engineers, or technical specialists, as you can see there. We operate as a not-for-profit organization, and so in that we have a budget of projects that we're responsible for a total obligation authority of about $2.7 billion. So we have a lot of work and a lot of efforts going on here in San Diego. We do that with our spreading our workforce, whether we're getting new professionals, which are new college graduates, and we've had in the past year approximately 2,700 applicants, and we hire out of those about 86 positions. So we take the very cream of the crop of new professionals, college graduates, and scientists, engineers, and give them tasks that ultimately grow them into being the next major developer, system engineers for the future Navy-related systems. We have quite a few advanced degrees at our organization because it's necessary in this high-tech world of having the technology and the skill set in order to contribute to the generation of technologies that are coming up. So just to talk a little bit more about that funding is that in how we work out of that $2.7 billion, $1.2 billion of that immediately goes out to support to contracts. And of that, that happens year in and year out. So we don't take and hold on and use those funds internally, but we will contract that out and provide either small business or large business in order to do that. We, in our small business relationship, we hit all of our targets and exceed each one of those. And of our top 10 contractors that support us, 8 of those are small businesses. So we have a great teaming relationship and technology injection that comes from the community, such as those of you that are represented here. So how we actually do this is we focus on technologies that are here today, tomorrow, and that are coming up in the future. And we do that whether it's today's work is a lot of installation and support, and so whether it's the 800 installations that we've done last fiscal year, there are a variety of ships. We're constantly working with ship schedules and getting technologies introduced to each one of those. We use a lot of different technologies in order to do that and keep up with that, because many times end of life of products happen, and so we're heavily starting into how to keep the logistics and maintenance capabilities there, and so looking at 3D additive manufacturing, and in order to recreate products that have end of life or the company no longer supports those types of products. But a lot of the ships last for very long periods of time, and they aren't cycled quickly on getting new designs out, and so we must support those over time. Working on technologies of tomorrow, so those end up being things that are close to being fielded, whether it's the unmanned underwater vehicles, such as the ONR one that's demonstrated there. We work on the mine hunting vehicles, the Mark 18 and family of products that have been advertised quite heavily in the maritime industry of a REMA 600 vehicle that go out and do surveys and find mine shapes. We also support a variety of organizations. So the Enhanced Polar System Gateway is a satellite ground terminal, because the Navy has to operate at all latitudes, and not all satellites have polar gateways capabilities. So the Air Force, in managing their satellites, came to us to build a ground station in order to support, have a Navy purpose and a Navy mission supported for their satellite communications. In the future, we're doing a bunch of research. One that's shown there is the cryogenic exploitation of RF, which is how to make antennas electrically small and relying on cryogenic technologies in order to make them efficient when they're extremely electronically small. A lot of work is going on in nanosatellites. We want to be able to put up satellites at will, very quickly, very inexpensively, that will support a variety of different missions. So we're working on how to build and test and design those type of systems. So at our organization, we have a variety of unique facilities and infrastructure, whether it's many years ago, the acquisition community was designed as go out and buy a system and then go straight in and do an installation on the ship, which generated a lot of problems because the ship is a very integrated system of systems. So we created enterprise engineering and certification facility so that we could install them first in a fully mocked up laboratory, wring out all the problems, and then deploy them. One of the things that we have as a unique facility is our San Clemente Island. It's a marine test and evaluation environment located 60 miles off the coast here, where we'll be able to dive and put systems under the water, operate them, test them, cables back to the shore, and gets us a true marine environment in order to test these items. We have several science and technology focus areas that are listed here, whether it's underwater, laser-based underwater comms. One project that we're working with ONR is FIDECO, the Forward Deployed Energy and Communications Outpost, where it's the ability of trying to design systems that have a cellular-based kind of style of communications and energy located at various geographic places under the sea. So that's an effort that we're working on. We're doing a lot of research in areas such as graphene, trying to use graphene to be the next generation laser system and get work on getting light emission from graphene, a very high-tech, very basic research kind of technology area. So of all the list of items that are there is a lot of technologies of those 4,800 individuals that they're working on in order to create the next breakthrough, the next technology that will make our naval forces operate better. So of those technologies, we don't hold on to them as specifically as they only are used by the Navy and our contractors. So we have an intellectual and capital and partnership capability. It's a large area of focus for us of how do we transition technologies, whether it's transition them further down the development path or transition them to individuals, whether it's organizations, et cetera. So you can see on this slide here that there is one of the ways we do that is we do cooperative research agreements. And so we will create an agreement where we'll work with partners and develop a new technology and share information back and forth on how that technology will help them and how it will help the Navy. So there are many of those research agreements that we have in place to do that. We do some education and outreach in our communities. So we host a yearly in late July, early August timeframe, we host the robotics challenge, the AUVSI robotics challenge here. We do that out at, we have a large, and I'll talk about it in a minute, a large pool facility where we do this in water. And so the advantage to us in the government ends up being that we get to see the new technologies and the innovative techniques that a lot of universities and even high school students can generate to work through each one of those challenges. We have a very strong emphasis at our organization to support the science and technology, engineering and math STEM programs across San Diego County. We have a lot of volunteers, a very engaged and vigorous group for working with the LEGO Robotics League here in San Diego. Back again on the patents, you can see that we produce and generate a lot of patents. The Navy is one of the world's largest patent producers, and we are at SSC Pacific, we're one of the major contributors to the Navy in doing that. So each one of those technologies can transfer, where we've done it through a variety of different organizations that will buy patents or will license them. There's been several of those licensing opportunities that have kicked off small businesses, which became large businesses here in San Diego. The one that was a fairly large one that I remember was Peregrine Semiconductor, which was based upon patents that were developed at our organization, and then became a large influence in the semiconductor and cellular worlds. So our ultimate goal here is to rapidly develop and deliver these critical capabilities for national security. And so relying on that C4ISR, the glue between the systems on how to make them better. We're doing it from seabed to space. We're looking at a variety of how they operate securely, because that's a very important, cybersecurity is a very important piece for us here in the Navy. And whether it's the ISR systems, whether it's air, we work heavily with other organizations for command centers. So for example, the Ballistic Missile Defense Agency. So we're working cross Navy and across the DoD for any of those systems. So looking at the time, let me move on and talk more specifically about a couple of different projects that we do at SSC Pacific, that their capabilities related to the innovation that we're working on and the partnering and the teaming that we have doing that. So I mentioned briefly TransTech is that this is one of our unique facilities that we have in San Diego. It's a 6 million gallon pool. It's 300 by 200 feet, where we do a lot of acoustics, sensor-related testing. We also use it for a lot of the unmanned vehicles, and you can see a couple of those that are shown there, whether it's our industry partners or it's universities. The one on the right is from a university in China, which is quite unique for us to be working with. But there's a lot of work due to that because of our capabilities that we work with a lot of things, a lot of organizations. A lot of work going on in that kind of in that FIDECO land of how to get unmanned vehicles to dock. It's a very challenging environment. We've done some work in our Transtech pool. We've also taken it out to San Clemente Island and done an open ocean testing. So we've gotten the reliability extremely high with these techniques, and this is an effort where we're learning so we can help DARPA, and then DARPA can transition technologies to industry so that we will create the next generation of reliable systems for docking. In this last little bit, let me talk about the Navy's next unmanned system, the new class of ships, the medium displacement unmanned surface vehicle. This is currently it's a DARPA effort. This ship is called the Sea Hunter. It arrived here in San Diego a few months back. It is a unmanned vehicle. Its original design was to be a continuous trail, so follow a submarine and do anti-submarine warfare operations. So it had a lot of design specs that were specific to that, and in there, one of the major technologies that's being developed is how to operate with the collision regulations, and so that it can operate autonomously. We joke about this particular ship is that while it's here, it may be the unmanned surface vessel, but it's not unmanned while we have it here in San Diego. It is, we have a captain on board because we're still testing all the autonomy related that's being designed into that ship. One of the things that it's been expanded to be used for ends up being a project that DARPA's been developing, and this is to put a towed system that will fly behind the ship and put a payload, an RF payload, at an altitude that will get you a longer sight range RF horizon. So you can see this here is a parafoil that gets launched off the ship. The ship is traveling about 15 to 20 knots here, and then this parafoil is flying about 1,000 feet. So it increases the radio horizon and has the ability to either be a comms relay or a surveillance system. But this is one of the things that's been tested here in San Diego, and that's a future capability for the unmanned, for the Sea Hunter. So one of the technologies that still needs to be developed related to this is that surface ships still must maintain compliance with regulatory requirements. And so the Navy, being the largest supporter of research related to maritime compliance, is that we're looking at the problem of this is currently surface vessels rely on humans to do collision avoidance of marine mammals. And so when you get an unmanned system, that doesn't jive. There needs to be an unmanned capability in order to do detection of marine mammals so that we can avoid them and not have any strikes against them. And then we need to determine what's an acceptable level for detection, because humans have a certain ability to detect. We need to make sure that we develop a technical solution that will do the same thing. So we're teaming with DARPA in order to do this, and we have several SBIRs that we're going to be issuing here shortly to work on and develop a technology that we can integrate into the unmanned surface vessels. So one of the things that we also do at the center is we participate heavily in fleet exercises and experiments. So this one is coming up in the spring this year, and this is not only supporting the Navy but also the Marines, and this is the Ship-to-Shore Maneuver Exploration and Experimentation Task Force. It's the problem of how do you integrate unmanned systems that support the landing of our Marine forces. And so this exercise is that we participate. We're not running this, but we're partner with industry and use our own technologies and put pieces and systems together to demonstrate how to actually support in an unmanned way this landing force. And if you're interested in participating, that's not through us, but if you do the search on S2ME2, you'll find the website that will talk all about that participation and how you can enter. And it currently says that the October 31st was the deadline for submissions, but talking to people on the team that the email is still active, and if you have submissions, they may be able to consider it. So just a heads up on something that would be very useful in that teaming relationship. So finally, in our future trends category of what we're really working on is cyber is a huge piece to us. We have to bake in cybersecurity up front, and that generally does not happen because cybersecurity is kind of the antithesis to having good communications. It's if you don't do it right, communications doesn't happen, and that makes it difficult. But in order for us to buy and develop and use any systems that are going forward, we have to have that cybersecurity built in up front. We're working heavily on cloud computing because ocean data is very extensive, and there's a large amount of it, and we need to be able to process it. So we're heavily working on that. We have large efforts, as I've demonstrated already, related to unmanned systems. And one that I haven't even talked about is focusing on energy, but it's related to unmanned systems, is that in order for these unmanned systems to work, we need to have efficient, a huge amount of efficiency and power systems that will support each one of those. So just kind of in summary, let me tell you is that I think this is this field is very challenging, very difficult, very exciting. There's new things that can be developed and solutions that can be proposed, and there's a lot of problems that are needing of attention, and there's a very bright future in developing systems. And so in kind of the summary of quote again from Henry Ford about how we need to work together is that if we're all moving, if everyone is moving forward together, then success takes care of itself. I appreciate your time and your consideration, and I'll be, if you need to talk afterwards at a break, please find me. Thank you.
Mark. Mark, thank you for that. Just one question, and appreciate that you'll be here all morning. So if other people have questions as well, there'll be time for that. Since the theme of BlueTech Week is case studies of collaboration, you've had a number of case studies of collaboration. Curious about one of them. A couple years ago, the Secretary of the Navy, I understand, basically created a senior level position within the Navy to integrate unmanned systems, aerial, surface, and undersea. And that's a great example of collaboration. How's that going? What are we looking forward to? What can you tell us about that?
So within the Navy has created and is reorganizing currently into supporting many of these autonomous unmanned systems. And so N99 is the position that's been created kind of as the grand poobah of trying to organize a variety of those systems. And so that's and it's working across all domains. So the teaming relationship and has a case study of before the N99 was stood up is that the command and control capabilities were very specific to each of the domains. Air, flying unmanned vehicles, they did their own systems. Underwater vehicles, they did their own command and control. Currently, the N99 is trying to put together the requirements and the designs in order to maximize that so that each one of the domains can operate a little more seamlessly. It's hard to, here's an example we had is that we needed an operator of an unmanned underwater vehicle, and so we went out to the active duty Navy and we said, hey, can you provide us somebody who has experience in that? They sent us one, and immediately we said, okay, great, let's get started. And the first question that was asked, and we're operating these underwater vehicles, the first question they asked is, where's the joystick? I'm going, we don't do it that way. And so just kind of a mindset of between all the domains of getting together and thinking these unmanned systems a little bit better and how they integrate and work together, because many of these systems are going to be multi-domain. So whether it's an underwater vehicle working together on directing a surface vehicle that will also launch an air vehicle, there's a lot of needs and research doing that. So there's several different areas that are working in that way of trying to work together, team, get some cross-collaboration and some advantages in learning from each other.
Great. Thank you very much for your time. Thank you for being here, Mark.
Thank you.